in a hot, dense state that nearly 14 billion years ago expansion started. Wait, the earth began to cool, the autotrophs began to drool, Neanderthals developed tools, we built a wall. We built the pyramids, math, science, history, unraveling the mystery that all started with a big bang.
Katie? Katie?
Shoot,
Katie, open up. Katie, aren't your scholarships due today?
No, Wednesday.
It's Thursday. But listen, Katie, sometimes people, good people, start solving these math problems and through no fault of their own, get kind of addicted.
Yeah? Get to the point. I'm really close to solving this.
Katie, you've got Oreos in your hair.
How do I find a number that if squared is equal to 11?
Let's see. Well, is it a continuous function?
Yeah, because it's a polynomial.
Try using the intermediate value theorem. So, what's the problem you're working on right now?
Use the intermediate value theorem to prove that there is a real number that's equal to square root of 11. That is, prove that there is a real number c such that c squared equals 11.
So have you found a number that if squared is less than 11?
Well, that's 3, right?
Yeah.
Okay, so I found the intermediate value theorem definition in my notebook. If the function f is continuous for all x in the closed interval ab, and y is a number between fa and fb, then there's a number x equals c in ab for which fc equals y. If our function is x squared, then f of 3 equals 9, f of 4 16, and f of c equals 11.
Now write it as an inequality. F of 3 is less than 11, which is less than f of 4.
Oh, so there's a value between 3 and 4 that 1 squared equals 11.
You
So
got it.
c equals the square root of 11.
That's exactly right.
Yay!
In this example graph, we've drawn a graph of our function y equals x squared. We marked the a and b values, in this case 3 and 4, along the x-axis. And we have f of a and f of b, or 9 and 16, along the y-axis. Because c squared is 11, and in between 9 and 16, we marked that on the graph and drew a line to show where its corresponding x value is, between 3 and 4.
Okay, just to make sure I have this straight, if I'm trying to find a number c that when squared equals 11, I know that f of x equals x squared. And because f of x is a polynomial and all polynomials are continuous, the intermediate value theorem applies. I found that f of 3 equals 9 and f of 4 equals 16. And so because 11 lies somewhere in between 9 and 16, I can assume that c lies somewhere between 3 and 4. Therefore, there's a number of x equals c between 3 and 4 such that f of c equals 11. And by definition of a square root, that number is the square root of 11. QED. We got it!
Good job! And now
Thanks.
that you solved that problem, I'm going to let you get to your scholarships.
Why did you choose this topic?
Well, we chose this topic because it seemed familiar to us, but also we needed to refresh our skills. So we thought this would be a good way to do it.
We also didn't spend that much time in class to thoroughly dissect the intermediate value theorem. So we thought we'd enhance our learning by doing our video project on this.
What did you learn by doing this project?
Well, we had to go back into the textbook and back into our notes to reteach ourselves how to do it. So personally, I relearned the entire process.
What did I learn? I learned that explaining topics and explaining how we solve things also teaches you more about the subject.